Hi, in this session I am going to discuss continuous probability distributions. Continuous probability distributions are defined using three parameters. The first one is scale parameter. Scale parameter defines the range of the continuous distribution. The larger the scale parameter value, the larger is the spread of the distribution. For example, when we talk about scale parameter of a probability distribution, let us say I am going to take lambda as the scale parameter. If the scale parameter value is small, then we may have a curve something like this, or when it is large, we may end up with a curve which is something like that. So, if you look at the range is large for the second distribution compared to the first distribution. In case of normal distribution, the standard deviation is a scale parameter. So, let us look at what happens in a normal distribution. When the standard deviation is very low, which is the scale parameter, the distribution will be much tighter, and when the standard deviation is large, the distribution will be much shorter, but the range will be much longer. So, here this is captured by the scale parameter, and in this case, or at least in the normal distribution, that is captured by the standard deviation of the normal distribution. The second parameter is the shape parameter that defines the shape of the probability distribution. The changes to the value of shape parameter will change the shape of the distribution. So, let us try to understand how the shape parameter works. So, basically the shapes of the probability distribution can be something like this, or it can be a symmetrical shape like in the case of normal distribution, or it can be a skewed distribution. Here I have drawn a left skewed distribution, or you can have a right skewed distribution, something like that. So, what we see here is different shapes of the distribution, and this shape of the distribution is captured by the shape parameter in case of probability distribution. For example, variable distribution is one of the distribution which has a shape parameter, and the probability density function of the variable distribution, or the shape of the probability density function of the variable distribution, will depend on its value. For example, whenever the shape of the parameter is 1, the variable distribution will be simply exponential distribution. So, the shape of the variable distribution will be exactly same as exponential distribution. Whenever the shape parameter is greater than 3, it will be more like a normal distribution, that is a symmetrical shape, and when it is less than 1 or greater than 1, it takes some kind of skewed form. So, it can have a shape something like this or shape something like that. So, here the different shapes of the distribution are captured by the shape parameter. The third one is the location parameter. The location parameter locates or shifts the distribution on the horizontal axis. For example, for normal distribution, the mean is the location parameter. Depending on the value of the mean, it gets shifts across the horizontal axis. For example, let us assume that the mean of the normal distribution is 100 and sigma is 10, and another case is mean is 200 and sigma is again 10. So, if you look at the difference between these two distributions, the shape will be exactly same except for the location on the horizontal axis. That is, if we draw these two distributions, we will have one distribution like this, where the mu is 100. The other distribution will be exactly similar, but only thing is it gets shifted, and we are looking at this value which is 200. So, basically what we are seeing here is that the location parameter locates the probability distribution on the horizontal axis. So, it moves the distribution on the horizontal axis. Note that not all probability distribution will have all three parameters. For example, an exponential distribution is a single parameter distribution, and normal distribution has a location parameter which is nothing but the mean of the normal distribution, and a scale parameter which is a standard deviation of the normal distribution. Why we do not have shape parameter for normal distribution? The answer is simple, because all the normal distributions will have the bell shape or symmetrical bell shaped curve. That is why we do not have shape parameter for normal distribution.